Good afternoon. Let us start our lecture today. So today we are not going to continue PDEs, but we're gonna do the practice exam. So the midterm will be next Thursday in class midterm. If you are that student, today is the last day that you can register for the DAS accommodation, right? So so be quick, otherwise you will not be able to do the
The last date for which now?
for the DAS student, DASS. So if you need special, proctoring for the exam and you need more time, you have to do it with the DAS. Because on next Thursday, I'm gonna have 2 exams. So I'm not going to be able to proctor the DAS students. So it's better that you go online and schedule it with them. All right, and today is the last day. It's clear? So if you are not, so if you forget to do it today, you're gonna do the normal exam with the other student. Because again, on next Thursday I have 2 exams to proctor, and I am not able to provide you extra time for your exam. All right? Clear? Questions? All right. So today we are not going to continue PD class, but we are going to do the practice exam. I put the practice exam with the solution online, so you can find the solutions on Canvas. But I'm gonna try to explain to you the main points of the exam. So the main exam will be exactly the same. I mean the same form. So I'm gonna change the numbers, the function, but this is the kind of question that you're gonna have in the actual exam on next Thursday. You're gonna have 4 questions. Each question will be 5 points, and you're gonna have the total points of 20. The maximum will be 20, right? So let us try to do the practice exam. Problem number 1, compute the Fourier series of fx to be x squared. X is going from minus pi to pi, and f is 2 pi period. All right, this is the function that you have to compute the Fourier series. Again, for the first exam, we are not going to do equation. We're just checking Fourier series, how you compute those Fourier series. Now, so we're gonna have the formula. So in this case, L is going to be pi, right? So we're gonna compute Bn. Bn will be 1 over pi, integral from minus pi to pi of fx, sinus of n pi x over pi dx, right? But here you have pi, so I can forget about pi over pi, so it's gonna be this one. Yes?
Can we assume that since it's x squared, that f of x is an even function, so b of n would be 0?
Yes, this is something that we have to check. Yes, right. Well, this is what we are checking now. So we observe that this is an odd function, right? Fx sinus of n pi x is an odd function. All right. So because f of minus x sinus of minus n minus x is x squared, right? So this is x squared minus of sinus of nx, and this is minus of fx sinus nx. So the first thing that you check in this computation is if this is an odd or an even function, right? So you have that fx sinus nx is an odd function because when you replace minus here, you're gonna get minus x squared, which is x squared, and sinus of minus nx, and this will become minus sinus nx. So this gives you minus of fx sinus nx, right? So this is an even function. The reason for this is because fx is an even function, right? Remember? So fx is x squared is even, and sinus nx is odd. So fx is x squared is an even function, and sinus is an odd function. So when you multiply an even function and an odd function, you get an odd function. So fx times sinus nx is odd. So you have what? You have even times odd is equal to odd, right? Explain again. So before doing anything, the first thing that we have to do is to check if this is an even or an odd function. Of course, in this case, this is an even function because when I replace minus here, minus and minus, I'm gonna have f of minus x sinus and minus x. So sinus and minus x will give you minus sinus and x, and f of minus x is x squared. So this gives you minus fx sinus and x. Which means that in this case you have an odd function. To be more general, if you have an even function, in this case fx is x squared, and x squared is an even function, and sinus is an odd function. Now you multiply an even function with an odd function, then you get an odd function. So even times odd is odd. Questions? It's good. Right. So in this case, because this is an odd function, so Vn will be 0. Right. So in this case, Vn will be 0.
Will we have to write all of that out as proof on the test, or can we just say we know that the function is even, therefore Bn would be 0?
No, you have to check that this is even.
You have to check that.
Yes. I mean, this is easy and it won't take you time, but you have to check it. You cannot say that this is even, right? I mean, this is just show that you understand this. So Bn is going to be 0. Now we're gonna compute A0, which is integral from minus pi to pi of 1 over 2 pi. All right, x squared dx. Right, so for this one you can say you can use even and odd, but this is standard, right? So the antiderivative of x squared is what?
1/3 x cubed.
1 over 1/3 of x cubed, right? Minus pi, pi. So A0 is easy to compute because you just have to take the antiderivative of x squared. So antiderivative of x squared is x cubed over 3. So here I have 1 over 2 pi of x cubed over 3, and this is evaluated from minus pi to pi. All right, so this gives me 1 over pi, pi over 3 over 3, and this is pi squared over 3. Right? So here I'm gonna evaluate at pi and minus pi. Right? So let me write more carefully. So I have 1 over 2 pi, pi cubed over 3, minus power 3. Right? So it's going to be pi to power 3 dividing by 3 plus pi to power 3 dividing by 3. All right? So this is 2 times of pi power 3 over 3, and so this is 1 over pi to power 3 over 3, and this is pi squared over 3. It's clear? Questions? Now let us continue with IN. 1 over pi, integral from minus pi to pi of fx cosinus of nx dx. All right? It's good. Right. So in this case, again, you're going to see that this is an even function, right? So fx cosinus nx is even since you have what? You have f of minus x cosinus of n minus x will be minus x squared cosinus of n minus x, and this is x squared cosinus of nx, and this is fx cosinus of nx. All right? So in this case, you have an even function because when you replace minus into x, f of minus x cosinus of minus n of minus x will give you x squared cosinus nx, and this is fx cosinus nx. Right? Which means that here you only have to compute the integral from 0 to pi, so an will be 2 over pi, the integral from 0 to pi of x squared cosinus of nx dx. Good? Questions? Now, how can we compute this integral?
Integration by part.
Integration by part, yes. So again, integration by part will be something like this. U dv is uv minus v du. All right? So in this case, what is u and what is v? Right. Can you say at the back of the paper, please? All right. So in this case, you're gonna group all of the polynomial, and you're gonna group all of the cosinus and sinus. All right. So in this case, u is going to be x squared, and dv will be this guy. So u will be x squared, and dv will be cosinus nx.
Shouldn't the v be behind the integral, like u minus the integral of v du in the formula?
Yes. Can you sign at the back of the paper, please? All right. So in this case, we're gonna choose u to be x squared and dv to be cosinus n pi x dx. All right. It's good. Right. So in this case, what is v?
Sine of x over n. Sine of nx over n.
I want you to raise your hand. Okay. So can you sign at the back of the paper, please? v is sinus of nx over n. All right. Because in this case, v prime will be cosinus nx. All right. So dv will be cosinus nx dv. So v will be the antiderivative of cosinus nx. So v will be sinus nx over n. Now, so I'm gonna use integration by pi, 2 over pi. Integral from 0 to pi of, so I'm gonna replace this here.
Would du be 2 dx?
No,
No? 2x dx?
2x dx.
Okay, all right.
So now I'm gonna replace this here, and this is 2 over pi. So I have uv, so this is x squared cosinus nx. You take the difference between 0 and pi, all right? So this is uv. This is uv. Minus the integral from 0 to pi of v du. So v will be sinus of n pi x of n du will be dx squared. All right? Yes? There's 2 over pi. Yes.
Oh, no, on
No,
the
the v.
side, you have u times v, you have x squared times cosine.
Your
Should
v
be x squared
term is
times sine.
sine of nx over n, but you wrote cosine of nx.
Yes, thank you, yes. Can you both sign at the back of you, right? Can you both sign at the back of please? Sinus and pi, right? Thank you. So here you have UV, right? So you have x squared sinus n x. Here you have the product of u and v. This one we give you 0 because sinus of n pi is 0. Sinus of 0 is 0. So here you have v du. Still have
It's sine nx over n, isn't it?
yes. Over n. Yes, can you sign the paper again, please? Right. So there's a dividing by n, right? So this is going to be 0. All right. So I have. So there are some students who asked me about the what is the value of sinus nx. So you have what? So you have sinus of 2 pi n plus x is sinus of x. Sinus is a 2 pi periodic function. So sinus of 2 pi n plus x should be sinus of x. Right? Now, if x is 0, you have sinus of 2 pi plus 0, right? Is sinus of 0. And this is 0. Alright? Now, if you have x is pi, so you have 2 pi n plus pi is sine of pi, and this is also 0. Alright? So which means that sinus of 2n plus 1 pi is 0. Right? Now you combine the first and the second case, you're going to have what? You're going to have sinus of n pi is going to be 0. Yes?
At the end of did you put the x squared there on purpose?
So this is dv. This is dv.
No.
This is du, right? This is du. I'm going to come back to that later.
So you did it on purpose?
Yes?
Okay.
So this is du. So you have v du. So du is x squared. So this is vds. This is dx squared is du. Right? I'm gonna recall to you. I'm gonna come back to that later. So let me explain this because some students asked me about these values. All right. So you have sinus of x is a 2 pi periodic function. So this is why you have sinus of 2 n pi plus x is sinus of x. If you replace x to be 0 or pi, you're gonna get 0. You combine them, you get sinus of n pi is 0, right? Now, so you have sinus of 2 n pi plus pi over 2, and this gives me sinus of pi over 2. So you replace x by pi over 2, so this is 1, right? Now I have sinus of 2 n pi plus 3 pi over 2, and this gives me sinus of 3 pi over 2, and this is minus 1. All right? So the first one will give me something like sinus of 2n of 4n plus 1 pi over 2 is going to be 1, and sinus of 4n plus 3 pi over 2 is going to be minus 1, right? So basically, if you ask what is the value for sinus of m pi over 2, you have to consider all of those cases. You consider the first case, m is of the form 4n plus 1. So if m is 4n plus 1, this is going to be 1. All right? If m is 4n plus 3, this is going to be minus 1. It's good? And if m is an even number, this is going to be 0. So in general, there is no formula for sinus of m pi over 2. But you have to have 3 cases that I explained here. All right? So in this case, I have sinus of n pi, so it's 0, and sinus of 0, this is also 0. So this guy is going away. Questions on the sinus stuff? Right? So basically, this is the thing that you have to keep in mind. And this is based on the 2 pi periodic of the sinus function, and you can recall all of those things by remember what is sinus of 0, sinus of pi over 2, sinus of 3 pi over 2. Right? Right, so let us go back to this computation. So here I have what? I have v, which is sinus of nx over 2. And here I put dx squared, which is du. This is du. So what is d of u?
2x dx.
So if you have a function of x, you have a function fx, this is the function, right? So df will be f prime times dx. All right? It's clear? So this is why in differential equation you see something like this. Du over dt is equal to 2. Right? So you have to find a function u such that the derivative of u with respect to t is 2. This is equivalent with the fact that, okay, here I have df. So this notation is df over dx is f prime. Right? So this writing is equivalent with u prime is equal to 2. Right? It's clear? This is why here I write dx squared. So dx squared meaning that I'm going to take the derivative of x squared and I put dx. It's good. Right, so this is going to give me minus over pi, or 2 over pi, integral from 0 to pi, sinus of nx over n times 2x dx. Dx squared will be x squared prime dx. It's good. This is why this formula can be written in the following form. You have uv prime dx is uv minus v u prime dx. All right. So sometimes you see the integration by pi is written this way. Sometimes you see that this is written this way. This is because u prime dx is du, and v prime dx is dv.
That should be
dv.
dv.
V prime dx is dv, and u prime dx is du. Right? It's clear? Right, so now let us try to compute this guy. So this guy I have 2 over pi, integral from 0 to pi, sinus n pi over 2x dx. Now I'm gonna have minus 4 over pi. I'm gonna put all of the constant outside and have sinus nx x dx. So what is the next step? Yes?
We integrate the parts again.
Yes. So what is the u?
The u would be the x, well, yeah, the x and the u would be the
Yes.
same.
Can you sign the back of the paper, please? All right. So here I'm gonna choose u to be the x. So whenever I have yes. So I have 2 over pi right here. I have 2 over pi and 2n. So I have 4 over.
Yeah, there's another 2 in the pi.
This is 0.
Yeah, but that 2 in the pi goes over all of the.
It was
You already distributed.
factored, distributed out.
Oh, okay.
So this 2 over pi is here and here.
Okay.
So now I have to compute this one. I have the u, and this is the dv. All right. So whenever you have an integration by pi, you're gonna group all of the polynomials to one guy, one u, and all of the cosinus and sinus to dv. Right. Now I'm gonna have u is going to be x, and dv will be sinus of nx dx. So what is v? Yes?
Negative 1 over n cosine n.
Can you sign the back of the paper, please? So v will be minus cosinus of nx over n, right? That's good. Now I'm gonna try to do it again. So here I have 4 minus n pi. I have uv, which is sinus of nx, and minus cosinus of nx over n. And this is from 0 to pi. All right?
Why is it sign that?
No, it's x.
Yeah.
Can you sign the back of the paper, please?
Got me terrified there for a second.
So now you have what? You have plus 4 over n pi. The integral from 0 to pi of minus cosinus of n x over n du, and in this case you have the x. Right? All right? Questions?
It should be minus the second term, right?
This is minus the second term, but I have a minus, so I have minus minus, and it is plus.
I mean, over there, yeah.
Yeah, this is minus or minus.
Oh, those factored out, all right. Okay.
Other questions? Right. Now I have to compute the first term. So the first term will give me minus 4 over n pi. And then I have pi, and I have cosinus of n pi over n, and I have minus. Right? Yes. So what is the value of this? Yes.
Negative 1 to the n.
Can you sign the back of the paper, please? This is 4 over n squared minus 1 to the n.
Can you walk through those steps, how you got there?
From here to here.
Yeah.
Yes, so let me explain it. So we're going to use the periodicity of cosinus again, right? So you have cosinus n pi plus x is going to be cosinus of x. Right? Now I'm going to replace 0 here. So cosinus of 2 m pi will be cosinus of 0, and this is 1. Right? And 1 is what? 1 is minus 1 to the power 2m. Right? So, I mean, the key is that, okay, you remember this and you remember what is cosinus of 0. So cosinus of 2m pi plus x is cosinus of x. If you replace x to be 0, you're going to have cosinus m pi is cosinus of 0, and this is minus 1 to the power 2m because this is an even function. Now, let us replace this by pi. All right, so you have cosinus of 2m pi plus pi, and this gives me cosinus of pi, and this is minus 1, and minus 1 is minus 1 to 2m pi plus 1. All right? So cosinus of m pi, 2m pi plus pi is cosinus of pi, and cosinus of pi is minus 1 is minus 1 to the power 2m plus 1 because this is an odd function. It's good? Right, so I combine the two things here. I'm going to have cosinus of, so here I have what? Here I can write like 2m plus 1 pi. All right? So I combine this guy and this guy. I'm going to have cosinus n pi is minus 1 to the power n. Right? It's clear? Right, so this is why you have cosinus n pi is minus 1 to the power n. If you don't remember this formula, you can do it this way. Right? It's clear? Right, so the first term will give you this guy, and the second term, I'm going to have to do the second term. Right, the second term will be minus 4 over n squared pi cosinus n pi dx. So who knows what is it? Yes?
And the whole thing is 0.
Yes. So this is going to be 0 because the anti-derivative of this guy is sinus, and sinus is 0 on both sides. Minus 4 over, can you stand the back? N squared pi and here you have sinus nx dividing by n, and this is different between 0 and pi. So sinus n pi is 0, sinus 0 is 0. So this is going to be 0. Questions? So for the answer, you don't have to write a full series. You just compute a and bn, a0, and you will get a full score. Yes.
Are we allowed to use the integration by parts, like do you know the shortcut way?
I don't know.
There's like a shortcut you can do.
So how do you
make two columns? It's like your U and dv, and then you set your U and dv, and then you kind of like go by that, and
anything
it's
works.
Like
It's fine.
minus. Okay. Okay.
So if you do it correctly and you have the right answer, you get a full score.
Okay.
So anything is fine. This is math, so.
Okay. Sorry.
Anyone has questions? It's clear? Yes?
Can you just explain why that stays a negative in front 4 over n squared pi?
This one, right? So you have minus, minus, and minus. So this is why you have minus here.
But if you had a minus up there, and so at the top line, if you had a minus there and minus there, couldn't you just combine those?
Yes, so this is a plus, right? But cosine n pi is minus 1 to the n,
Okay.
right? It's clear? So basically an will be n squared. Alright? Other questions?
Can we ask them to turn the volume down?
You can try. Other questions? This is out of my control, right? Okay. Other questions? It's good. So let us go to the second exam. Again, this is another Fourier series. So you have number 2. Lx is going to be minus 1 when 2 is minus 1. And 1 when x is going from 0 to 2. Alright? And then we said that the function is f is for periodic. So, because this function is for periodic, we don't care about what happened outside of the interval, right? Yes. Right. So in this case, we're gonna compute an first.
Would these be considered even functions? No. So they would be odd functions?
So who knows what kind of function is it? Yes?
It'd be an odd function,
It's an odd function. Why?
because it's symmetric along y-axis.
Yes. Can you stand at the back of this? This is an odd function, right? Because when x is positive, f of x is 1. But f of minus x is going to be minus 1 because minus x is negative, right? If x is positive, f of x is going to be 1. But minus x will be negative, so f of minus x will be minus 1. So fx and f minus x, they have different signs. So fx is the minus of f of minus x, right? Yes?
So for the previous problem, we could have separated like we did here, like done the negative pi to 0, but we just kind of like shortcutted it. Is that kind of?
No, for the
In
previous one, for the bn function is an even odd function.
Odd function, yeah.
Right.
Okay.
So this is why it's 0.
Okay, yeah. No,
Right,
but
so-
you could show, you showed that, right? Like, you
Yes,
want us to
yes,
show
we
that.
show
Okay.
that, yes.
Okay.
For this case, function is going to be function is an odd function, and we're gonna see that an will be 0 in a minute. Okay. So this is so in the previous one we have an to be 0, and this one bn is 0.
bn is odd, right?
Yes, I mean the previous one bn is 0 and in this one an is 0, right? Yes.
It's an odd function.
Yeah. Now let us try to compute an. So an is going to be 1 over 2. Alright, so the integral from -2 to 2 of fx cosinus of n pi x over 2 of dx. Right? So this is the an. So in this case, an is fx cosinus n pi x over 2 dx. This is going to be 0, right? So f of x, when x is positive, you have f of x cosinus of n pi x over 2 is going to be cosinus of
I apologize.
n pi x over 2. Right? So in this case, f is positive, sorry. In this case, f is positive. So fx cosinus n pi x is going to be cosinus n pi x, all right? Because in this case, fx is 1. But f of minus x, cosinus of n pi minus x over 2 is going to be minus cosinus of n pi x over 2. All right? So this is minus of this guy. So this is an odd function. So an is going to be 0. Right? So again, the remark here is 1 because the function is even, is odd, and cosinus is an even function. So odd times even is odd. Right? So remark. F is odd. Cosinus of n pi x over 2 is even. So we have odd. Alright, so odd times even is odd. Right? I explain again. So in this case, f is an is an odd function, and cosinus is an even function. So f of x cosinus n pi x over 2 is cosinus n pi x over 2 when x is positive, because fx in this case is 1. F of minus x will be minus 1, so you have minus cosinus n pi x over 2. So this is minus of this guy, so this is an odd function, and has to be 0, yes?
So like on the homework when you were like saying, assuming this function is odd or even.
I give you the,
So it one would obviously cancel, like, so we're basically saying that, or we're just calculating the odd, like.
So in the exam, in the homework, right, so I said that the function is even. But I only give you the value from 0 to L, right? So I don't give you the whole value on the whole interval of the function, all right? So I said, okay, suppose that f is an even function and this is going to be 1 from 0 to L. So you have to know that, okay, from minus L to 0, this is going to be 1, all right? So if I say that, okay, this function is odd from 0, but from 0 to L, I said that this is 1. So on the other interval, it's going to be minus 1, right? So in the homework, it's a little bit tricky in the sense that I only give you information on one side. And if this is even, you have to say that this is going to be 1. But if it is odd, you have to say that this is minus 1, right? So it's tricky in the homework. Other questions? Screen, right? Right, so in this case, you have an is 0, all right? And of course, a0 is also 0 because a0 is what? a0 is going to be 1 over 4 integral from minus 2 to 2 of fx dx. Right? And we check that this is an odd function, so this should be 0. So an and a0, they're both 0. All right? Yes?
Do we not have to check for a n when x is less than 0?
When x is less than 0. Yes, when x is less than 0 is going to be here. Right, so when, I mean, it's the same. So here I check, I only need to check one case, because when x is negative, basically this is minus x.
Right.
Right? So it's symmetric. Other questions? Right, so let us try to compute Bn. So Bn will be 1/2 of the integral from -2 to 2 of fx sinus of n pi x over 2 dx. All right? So what can I say about this function?
It's odd.
No, I want you to raise your hand. Yes?
It's even, so you know that you can take the integral from 0 to 2 and multiply it by 2.
Right. Can you say the back of the paper, please? When you want to say something, please raise your hand, because some students say that, okay, they are not fast enough in speaking, so if you raise your hand, I can choose who is. I can distribute the extra points. All right. Now, so in this case, f is odd, right? And this function is odd. So basically, odd times odd is an even function. So f is odd, and sinus n pi x is odd. So I can say that this is odd times odd, and this is even, right? So this is even, which means that I only need to compute from 0 to 2, right? So Bn will be integral from 0 to 2 of fx sinus of n pi x over 2 dx. Right, in this case, fx is 1, so Bn will be 0 over 2 sinus of n pi x over 2 dx. What is the antiderivative of this guy? Yes?
2 over n pi times negative cosine n pi x over 2.
Yes. Can you sign the back of the paper, please? So this gives me minus of cosinus of n pi x over 2 over n pi over 2. And I'm gonna evaluate 0 and 2. Right? Now, this is going to give me cosinus of n pi over n pi over 2, and plus cosinus of 0 over n pi over 2. So what is cosinus of n pi?
I was gonna ask.
Yes? Yes, can you stand back? Yes?
Are we forgetting the 2 coefficient for this? Since
No,
we're doing
the
it
2
as
is cancelled with 1.
2 is canceled with 1, okay.
So here I have what? I have 2 over n pi. I have minus of minus 1 over n plus 1. All right? It's clear? So in this case, an and a0, they are all 0, and bn is this value. So here I can put minus 1 here, and I put plus 1 here. Good. Questions? Yes?
So why did you put the plus 1 again?
So this is what? This is minus of minus 1 to the n. And this is minus 1 to the n plus 1. Why? Yes?
You bring the negative, like bring it up kind of to the n power.
Can you sign the back of the paper, please? Yes?
Would it also be correct to put in, 1 minus 1 at the end?
1 minus, yes, it's also
Okay.
so in this case, this is minus of 1 minus to the n, so this is minus 1 and minus 1 to the n, right? So minus of minus 1 to the n, so you have minus 1 and minus 1 to the n, so you add the 2 power. So this is minus 1 to the n plus 1, right? That's good. Other questions? That's good. Right, so now you see that for questions number 2 is also easy, right? And then for exam it's going to be the same. If you know how to do all of these integration map out with sinus and cosinus, you're going to be fine. Yes?
So we're gonna have to distinguish, sorry, which ones are even and which ones are odd.
Right.
Okay, and then can we automatically say, like, we notice it, like, this
You have to
function
check,
is,
you have to
you have
check.
to show.
And the simplest thing that you can say is that first you check that f is odd or even, right? So at least you have to check that f is odd or even. So once you check that this is odd or even, then you can say that, okay, because f is odd and sinus is odd, so when you multiply odd and odd, you get even, right? Right, so first you check if f is odd or even. And then you know that sinus is even, is odd, and cosinus is even. Right? So in each case, you're gonna say that, for instance, if in this case Bn is f times sinus, so you say that odd times odd is even. So this you don't have to check, but the least thing that you have to check is f is odd or even. And after that, you use the formula odd times odd is even, and even times odd is odd. If you have an odd function and you multiply with an odd function, then you get an even function. If you have an even function and you multiply this even function with an odd function, then you get an odd function. But so sinus is odd, this is even. Cosinus is even, this is also even. But you have to check f is odd or even, right? By using the definition. Is it clear? Other questions? Yes?
Sorry, kind of just an algebra question. So on that second line, when you were applying from 0 to 2, the function,
Yes.
when you plugged in 2 for x, did you like pull it out? So you plugged in 2 for like so the line below that.
No. So when I plug 2 here, right?
Right. Then
So I have cosinus of n pi 2 over 2.
Oh, I see.
So I cancel 2.
I got it.
I got n pi. Yes. Other questions? Good. Right. So let us go to the next questions, which is a little bit more complicated. All right. So. So now I have a function which is fx. This is so you have fx, which is x. When x is from -2 to 1/2, and mx is 1 minus x. When x is from 1/2 to 3/2. All right, and f is 2 periodic. Right. Now. So how can I do the Fourier transform for this guy? Yes?
I don't know exactly, but I would think if we were able to adjust the boundaries to be from say like -1 to 0 on the top and then 0 to 1, and then adjust the functions to account for that, would that work?
Yes, that should be the way to it. Can you sign the back of the paper, please? So this function is 2 periodic, right? But this is not the standard one that we are trying to do from the beginning. So the function is defined from so this is 0, right? So here you have minus 1/2, here you have 3/2, right? So this is 2. So the function is like something like this, and this is periodic, right? But the interval is string because the interval is from minus 1/2 to 3/2. And the function that we are used to is from minus 1 to 1. So the idea is that you have to pull it to minus 1 and 1. Right? So that you have a standard function that we know how to do it, right? It's clear? So this function is defined from minus 1/2 to 3/2. Of course, it's periodic with period 2. So from 3/2 to 7/2 is going to be the same, but we are not used to this kind of function because the function that we normally do is symmetric. So it's going to be from minus 1 to 1 and not from minus 1/2 to 3/2. So the key idea is then, okay, you have to somehow pull this graph to the origin. So this is the key idea. But how can we pull it?
Adjust the, I'm sorry.
Yes?
Okay.
So you just said so.
Will we just shift the function
How do you shape it?
in parentheses, like 1 minus x in parentheses minus 1/2?
You have an idea?
I was gonna say, write a function that mimics the current behavior, but the bounds are from -1 to 0 and 0 to 1, so
Yes.
it would end up being,
Yes, and you have some idea?
I think we shifted too, like he said, but we shifted by, since it's too periodic, we will need to shift it by half, so it would be f of x minus half.
Right. So you're gonna shift the function, right? So this is 1/2 minus 1/2. You're gonna shift this function to minus 1. Right. So can you treat both sides back up the paper, please? So this is how we do it. So we're gonna define a new function. So we're gonna have g of x is f of x plus 1/2. Right? So what is the role of this function? This is the shift function. So the shift function is doing the job of shifting the graph from minus 1/2, 3/2 to minus 1, 1. All right? Yes?
Added as subtracted.
Good question. So is it adding or subtracting? Yes?
You add it because adding shifts it to the left when you're translating the function, and when you subtract it, moves it to the right.
Right. Can you say the microperfector, please? And you also say microperfector. So this is a good point. Should we add or subtract? Because add or subtract meaning that you shift to the left or to the right. So let us check. All right? So I want the function to be from minus 1 to 1. Right. So we want g to be a function on minus 1, 1. All right? This is what we want. We want the function g to be from minus 1 to 1 so that we can do the normal thing that we are doing. Right? So let us check. So what is g of minus 1? So g of minus 1 will be f of minus 1 plus 1/2. Right? And this gives me f of minus 1/2. All right? So which means that the f of minus 1/2 here is really moved to minus 1 here. It's clear? Right? So you have an f which is on minus 1/2 to 3/2, and I want to shift this to minus 1, 1. So I define gx to be f of x plus 1/2, So when x is equal to -1, g of -1 will be f of -1 plus 1/2, and this is f of -1/2, which means that I shift -1/2 of f to -1 of g, right? And I'm gonna check 3/3. So I'm gonna check g1. So g1 will be f of 1 plus 1/2, and this is f of 3/2, right? So which means that the value when x is equal to 1 of g is going to be the value of f at 3/2, right? Which means that the two boundaries now are -1 and 1 instead of -1/2 and 3/2. Questions? So you right. So you can you may not remember if you have -1 or mx is plus 1/2, right? So because this is shifting, so it's either plus 1/2 or minus 1/2. Other way you check is this: you plug -1 here, all right? So if suppose that you have minus, so you plug -1 here, and this f will become f of -3/2, which is not what we want, right? So this is where the way you should check it. Now let me try to write out the form of the function g. All right, so when x is from -1 to 0, x plus 1/2 is going to be from -1/2 to 1/2. All right. Now I want to find the value of the function g. All right. So when x is from -1 to 0, x plus 1/2 is going to be from -1/2 to -1/2. So g of x will be f of x plus 1/2. But f of x plus 1/2 is in -1/2, 1/2. So I'm gonna use the first formula, which is x plus 1/2. All right, it's good. It's clear enough. So I explain again. So when x is from -1 to 0, I want to compute gx, right? So by definition, gx will be f of x plus 1/2, but x plus 1/2 now will be from -1/2 to 1/2. All right, because x is from -1/2 to 0, so you just add 1/2 here. Right, so this is -1 plus 1/2, 0 plus 1/2. All right. So x plus 1/2 is from -1/2 to 1/2, meaning that f of x plus 1/2 is x plus 1/2, which is here. It's good. Questions? Now I'm gonna try to do x is going from 0 to 1. All right. So gx will be f of x plus 1/2 again. But in this case, x plus 1/2 will be from 0 plus 1/2, 1 plus 1/2, and this is 1/2, 3/2. Right? So the next case that I want to do is x from 0 to 1. When x is from 0 to 1, x plus 1/2 is from 0 plus 1/2, 1 plus 1/2, and this is 1/2, 3/2. Right? Which means that I can use the second formula, which is 1 minus x plus 1/2, and this is 1/2 minus x. It's good. Questions? So I explain again. I explain again. All right. So the function that I want, I define, is gx with f of x plus 1/2. All right. So this function is shifting f back to the -1, 1. Why? Because when I replace -1 here, I have f of -1 plus 1/2, and this is f of -1/2, which means that I shift the point -1/2 of f to -1. So if x is 1 f is 3 half, which is also good because I shift the point 3 half to 1. Now let us try to find the general form of g. So if x is from -1 to 0, x plus 1 half is going to be from, so I have to add 1 half to the two boundaries. So this gives me -1 half, 1 half. And in this case, g is going to be x plus 1 half. When x is from 0 to 1, x plus 1 half is going to be from 1 half to 3 half, right? So gx will be 1 minus x, but x is replaced by x plus 1 half, so I have 1 minus x plus 1 half, and this is 1 half minus x, right? So the new function will be very nice because this is 0, so this is defined from -1 to 1, -1 to 1, and this is like this. This is 1 half. So this is the function g. Right? The function g is going to be x plus 1 half here and 1 half minus x here. Right? So from -1 to 0, the function g will be x plus 1 half, and from 0 to 1, this is going to be 1 half minus x. So I'm going to write it here. So gx is going to be x plus 1 half when x is going from -1 to 0, and 1 half minus x when x is from 0 to 1. Questions? It's clear? Right, so this is the function that we have to do the Fourier transform, Fourier series, yes?
So can you just not solve the first one at all?
You don't.
Or would it just be different intervals? Like the f of x, the original function that they gave us, can we not solve that? Like we have to go through this process?
You have to go through, I mean, because you get, in this case, you're going to see that this is an even function, so you don't have to compute the thing. Right. So this is even, right? So when x is here, the graph is here, so I mean, if it's symmetric like this, this is, so I'm going to show you what is the graph of an even function. So the graph of an even function will be like this. No. So right. So the graph of an even function is symmetric using this y0 on this this one, and then the graph of an odd function will be symmetric, but through this origin, the origin point. So this is even, and this is odd. Right? So we want to shift back to the origin because we want an even function. And if we have an even function, we don't have to compute a lot. Right? So in this case, the function is symmetric with respect to this column, so it's an even function. So an even function is a function whose graph is symmetric with respect to this column, and an odd function is a function whose graph is symmetric with respect to this point, origin, right? So we always need to shift because we want an even or an odd function. And in this case, you reduce a lot of computation, and you reduce the mistake. Right. Other questions? Right. So let us try to compute the Fourier series of this function. Again, we need to check that this is an even function, right? So first, g is even. Because when x is positive, g of x is x plus 1 half. All right? And in this case, g of minus x is 1 half minus x. Did I make some mistake somewhere?
Here it should be x second one.
So the second one, this is x minus 1/2, right?
Yeah.
Oh,
No, it's x plus half.
wait,
No, that's correct.
It's
This is
correct.
correct. That's correct.
yes, yes.
Oh, so I make a mistake.
Yeah.
So x, so when I shift it back,
Yeah,
So say for
plugged
that, for
in-
that one.
so this is good, right?
Yeah, that's
Yeah.
good, it's for the,
Go to the other side of the board.
You just plugged in the
Whenever
equation
G
whenever
is
it's
even.
negative.
Plug in the
Yeah.
negative for the positive.
So I plug,
That should be minus.
yeah, that should be half minus x, the first one.
Yeah,
uh,
yeah.
yes, yes, okay, thank you, yes, yes. Yes, so, yes, so this is plus or minus x, right?
The g of x should be minus x plus 1/2. Because it's when x is greater than 0.
Yeah.
Yes, okay, thank you, yes, yes. So this is minus of minus x.
Go.
No, the
No.
first line is wrong.
Right.
It should be g of x equals 1/2 minus x
Yeah.
for when x is
Because
greater
x is
than
positive.
0. That's the equation for when x is
So
less than
here
0.
you have a minus.
Yeah, but that's when
No,
x
no,
is
no,
less
no,
than
no.
0.
That is
Okay,
correct.
okay,
Yeah.
thank you. So who discovered that?
Everyone.
Okay, so can all of you? Yes, so here I have minus, yes, yes, right? And this is basically g of minus x. So this is, yes. Yes, because I was thinking that this is for x positive. Right? So this is even.
I'm still lost on this.
Hmm?
G of x, like the way you have it written over there, g of x is essentially 1/2 minus x,
Right.
which is the positive g of x.
Right, this is here. And when this is negative, you replace the minus here. So it's going to be minus x, right? Yeah. Because minus x is negative. So you replace minus x here. So this is the same.
But it's because flipping the positive negative on the x still ends up with a part of the g of x function that's considered even.
I don't understand the questions.
You make the x negative,
Mhm.
and the resulting equation is still a part of g of x.
Right, so when x is positive, it takes value 1 minus x,
Okay,
right?
all right.
So when x is negative, it takes value 1. X plus 1/2, but in this case, negative x will be in the place of x, right?
All right.
Okay, so in this case, it's even, because it's even, right? So this is something that you check. So now we're gonna compute an. So let's just compute bn first. So you have bn is 1/2 integral from -1 to 1 of gx sinus of n pi x over 2. Right? So now you can say the following. So you say that g is even and sinus of n pi x over 2 is odd. Right? So the product of an even function and an odd function is an odd function. So this is odd. Which means that this is an odd function, so bn is 0. Yes?
Shouldn't it be sine of n pi x, not sine of x over 2?
Sinus of n pi x over 2, right?
L is 1, so.
Can you say it back like this? So in this case, sinus is an odd function and f is an even function as we check. So the product of an odd function and an even function gives you an odd function. So in this case, bn should be 0. Yes?
Well, where'd you get the 1/2?
Can you say it back please? All right? It's clear? Okay, so we have 1 minute, so let us try to compute a0. Okay, so we have no more minutes. So we're gonna continue this on Tuesday. So